Leave plot 1 on, but turn plot 2 on as well. And select this guy right here. He's your modified box plot. Now, you may or may not have messed around with this last week. It depends on how far down in that in-class quiz you got. At some point in that quiz, I had you turn this on to see if you had any outliers, and that's when I was analyzing your groups and trying to figure out if you did. If you have outliers, this one will indicate them using that method you just calculated out manually. Does that make sense? So if you just press graph now, there's your box plot. Notice, no outliers. There's no outliers. If there were an outlier, you'd see little dots. No dots, no outliers. You've got the whiskers, but there's no extreme values out here. No extreme values out here. What would it look like if you had an outlier? Let's just say. Let's create some fictitious data here.
Do 135.
What's, I was going to do 225. That's okay. There you go. We'll look something like that. Let's make the window better because I'm a window Nazi. There. It looks something along those lines, where you'd have your typical data, and then you'd have an outlier indicated like that. So that's what it would look like if you did have outliers. You guys are just so contained.
We're on it.
You're on it. Nailing the average. Actually, about 5 pounds below. Thank you very much. No, it's good. Fair enough. So, can you use this if you have bell-shaped data? Of course you can. This works in any case. But the beauty of it is it works perfectly when you don't. When you don't have any other tool. And the same limitations apply here as applied with other percentage data. You lose a little bit of specificity. No longer are you talking about absolute distances. You're now talking about just above or below. So you definitely have that issue to deal with. But at least it gives you something to deal with. It gives you something to deal with. Fair enough. I heard an interesting statistic, speaking of percentages, without looking at absolute values. 75%, was it 75 or 80? 75 or 80% of professional NFL athletes are bankrupt within a decade of leaving the NFL.
Yeah, I believe it. It's insane.
Crazy. You look at Ken Rutgers walking around here, who used to play for the Green Bay. And you know, he actually counsels his ex-teammates and ex-NFL players because of that. They leave the NFL and they just go through a whole, I mean, the 80th percentile for retired NFL income essentially is 0. Because they're bankrupt.
Brain disease.
It's crazy to think about when you think about it. So that's tight. The problem with using an average in that case is you don't want to. You don't want to use the multimillionaires that have turned their careers around and capitalized on that, because then you get a misleading view about the true center of what's going on, which I think that statistic captures beautifully. So that's why you want to look at relative position versus absolute position sometimes. Make sense so far? Please, Sarah.
I just got a little confused with IQR.
Yes.
How'd you get 1.5 again?
Dead good question. It's been handed down to us.
Oh.
That multiplier, it used to be 3, then it was shifted to 1.5. I don't know why it's not 2. I don't know why it's not 1.96. I'm not sure why it is 1.5. That is what is commonly acceptable right now.
Okay.
Wish I had a better answer than that.
Where did you get it? Like,
Somebody.
oh.
Somebody decided that that's the number of IQRs we're going to start multiplying.
Oh, so you...
Oh, no, it's basically plucked out of the journals. I mean, I have no good answer for you other than that. And the thing is, I can't even tell you that that's going to make sure you capture a certain percentage of data. Because the IQR captures the middle 50. But as soon as you multiply that by 50%, that doesn't mean you add another 50% on. It just means you've taken the length and moved it out 50%. That might capture no more data, that might capture double the data. It's not like the bell curve multiplication of 2. I wish I had a better answer. It's a crappy answer. It's a totally awful answer, but unfortunately it's the best answer I've got for you.
That's okay.
It's not really, but I appreciate your flexibility. I wish it was okay. It kind of drives me nuts, but.
I know, you like calculated it somewhere.
Oh God, no. Somebody, I'm sure, calculated a bunch of random trials. What statisticians will often do is they'll run a number of trials on randomized data and say, oh, it looks like 1.5 is trapping this much of the time. And then we'll start using that value.
The average.
Correct.
The average is showing up.
But who says that our data falls into that average? Our data might be wildly deviant. Our data set might be an entire outlier data set. So, I'm making everybody's head hurt. I apologize. So what I want to do is I want to wrap up. We got 2 methods of calculating. That's 4. We got 2 methods to calculate outliers. We got bell-shaped. If you have bell-shaped, by all means use the first. If you don't, by all means use the second. If you have bell-shaped, use the second one as well. How many of you are going to use the second because you can turn your box plot on and get it for free? Yeah, every hand goes up in the room. Yes, yes, because we like that. We like that very much. But nobody's asked the question I was hoping somebody would ask. Why do we care? And I appreciate that. I think that has a certain amount of trust involved. Because you guys trust I wouldn't fill your head with crap that was not important. There is no section in most stat textbooks on outliers. Like, I basically invented this section. So why would I do that? If it's not in a stat textbook, why is it important? Why do you care about outliers? Why would you care about outliers?
We need to know why we thought of it.
I love that answer. Let me come back to this Jared PowerPoint here for a second. I want to wrap up with a few examples of why you should care. So I was sitting in. This is just the next thing. Let's just sit back and let this wash over you. I want to analyze less numerically, more graphically. We're going to use the stuff from today in the analysis, but I also want to make sure that you guys kind of see the point. I was sitting in a colleague's class who's teaching what's the argumentative writing class? Is it 121 or 22?
122.
122. I was sitting in 122, and the kids were all broken up. Some of you guys might have been in this class, but I observed them last term. And the kids were reading out of, I call you guys kids, so you don't mind that. You're reading out of a book, and there was essays in the book. And the idea was the groups of 4 or 5 kids would then create, they'd pick an argument. Not like you're wrong, I'm right, but I'm going to debate my side. I think the author of this argument, or the author of this piece, has a valid argument based on their data. And the paper that I was so interested in was the caffeine in energy drinks is at unhealthy levels. And this person who wrote the paper clearly was pissed off at the energy drink market, at how they were mislabeling the amount of caffeine in energy drinks, and they were, well, this one here has 5,000 milligrams of caffeine, and that is blah, 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 blah. I'm like, okay, that's a good point. I'm pissed off too. That'll stop your heart like that. And I think some of them have actually been recalled to take up the market because they've killed people, I think. Could be wrong about that. So I did some digging. I did a little bit of digging, and some of the reports, caffeine info often misleading or missing on energy drink labels. I thought it was cute. The consumer group tested 27 popular energy drinks. Popular energy drinks makes me nervous, because you're only selecting a biased sample of those that are sold a lot. What about the one that has 5,000 milligrams? I mean, maybe that was not in there. Maybe. So anyway, I kept looking. Cardiac MRI reveals energy drinks alter heart function. Well, that's somewhat disturbing. Caffeine is up to 3 times higher than in other caffeinated beverages like coffee or cola. So then I got to thinking, like, okay, so what do they mean caffeine in coffee? So I used my friend Google, caffeine in a cup of coffee. 95 milligrams according to the good folks at Google. Now, that can be altered, of course, depending on how you brew it. So they're calling 95 milligrams per cup of coffee. A cup of coffee is also defined to be 8 ounces, 8 fluid ounces. So that's roughly 12, we're going to call that 12 milligrams per fluid ounce of caffeine in a cup of coffee. We'll go with that. Is that okay?
Yeah.
Just to give us a number. I think it's arguable that that's fairly average. So I kept thinking, I have a benchmark. At least I have a benchmark to discuss this article up here. And now I can start asking myself, are energy drinks outliers when compared to coffee? Because if they are, maybe these articles have a point. Maybe. So I kept looking. I stumbled upon the Caffeine Informer, gave me the website. It's a very interesting website. Very interesting. As far as I can tell, I just banned this video. I love that picture. As far as I can tell, they're fairly unbiased. Their point isn't to slam or support any beverage. It's simply to literally inform. As far as I can tell. As far as I can tell. The fact that they have ads on the side means they have no money, which is probably even more. They're not in somebody's pocket. There are 500 and some drinks listed. You can actually go to the site and use the scroll bar to scroll down. They've listed energy drinks in milligrams per fluid ounce. So you can see some of these numbers: 100 milligrams per fluid ounce in 5-hour energy, which is sold at most of the like 7-Eleven type stores. 500 in 5150 juice. 5150, FYI, is I believe the LA code for murder. So put that in. Oh no, excuse me, not murder. That was 187. 5150 is crazy person. Get hell no. Yes. Anyway, put that in perspective. So what I did was I went ahead and grabbed some of the data, i.e. all of it. That's some of it. That's some of it. I used my control copy paste into Excel, and then I got this. This is a partial listing of it. And if you look through that, this is all in milligrams per fluid ounce. We're comparing that to 12, right? 12 fluid ounce. Look through there. Anything jump out at you as potential outlier data?
Like 235.
235, 714,
434.
303.
714. Well, yeah.
This is per fluid ounce.
Oh my God.
So you figure, that's about as big as a rock star, right?
Right.
And this is
It's probably like
21 ounces. So multiply that times 21.
Oh my gosh.
Exactly. Then you're like, oh, you feel your heart stopping, yes? But here's the thing. Do we treat the whole data set because of the outlier 500? Is 500 even an outlier? Looks like it. So I went further, ran the whole data set into an online analysis. So now, can you see what I graphed? Something we've been talking about for the past couple days is in this image. Do you see it? It's vertical. You see it in this image.
It's really squished towards the bottom.
What is really squished towards the bottom?
Like
The box and whisker plot. Do you see it in there?
Right.
Go find it.
It's just
Min value, lower quartile, median, upper quartile. In case you can't see them, I put them over here. The minimum caffeine amount was 0. There were lots of zeros in that chart because lots of energy drinks don't have caffeine. They have things like chlorine, ginseng, vitamin B, oxidizers, right? Water. Oh, yeah, guarana. Exactly. Oh, guarana. I'm sorry. I used the water. I wasn't snorting it.
I love it.
So you've got a minimum of 0. Look at the median, 9.5.
Wow.
So half of them have less caffeine than a cup of coffee. Good, and half have more. Maybe. Keep looking. Keep looking. Third quartile, 12 and a half. Remember what we said about coffee? 12. Which means 75% of them have less caffeine than a cup of coffee. So all of a sudden, I start thinking about the claim in this article that caffeine, there's too much caffeine in energy drinks, and I start going, I don't think so. There might be something in energy drinks that's too much, but it doesn't look like caffeine. Especially when you have all these outliers, which are all indicated by the, look at that right there, 700 and whatever that's 20.
Yeah, what is that one? I'm staying away.
You have to go back and look at the chart. I have no idea.
714.
Oh, good, you got it. 714.3. That's per fluid ounce.
Wow.
Multiply that out by how many fluid ounces there are. So now, Lauren, I go back to your question. I go, okay, was that mismeasured? Should that have been 71.4 and we put the decimal place in the wrong place? Maybe, possibly. But even so, that would still be considered an outlier. And the reason is the IQR is wicked tight. It's only 9 units. 9 milligrams of caffeine. Why? These are ridiculously above that. So the reason I did this was to give the writing students kind of the point of, it's not that you should be focused only on that 5,000 milligram drink. The vast majority of, I mean, look, put 12, here's 25, here's 12. There's a cup of coffee. 75% of your data. The claim that they have more caffeine than a cup of coffee doesn't hold up to analysis. They got something, but it doesn't appear to be caffeine. See what I'm getting at?
Or wouldn't it be right to say that, like, only a few energy drinks have more caffeine?
Yes! But guess what? It didn't get said. That was not said in the article. They indicated the outliers as if they were Jared up on a pedestal. Thank you, Serenity. Yes, they should say that only, say, 10% have above 60 milligrams of caffeine per fluid ounce and therefore are labeled as dangerous. 1 in 10. But the implication is they all do. They all don't. It falls apart under analysis. Isn't that interesting? This is why you care. I mean, if you haven't already started caring. The idea is go look for this stuff. Let me show you a couple other ways to wrap it up. I'm talking about Larry Bird, we can skip here. Here's an experiment we do in Matthew 44 all the time. It's a bit of a facetious argument, but M&M says that's what should be in their candies. 24% blue, 20% orange, 13% brown, 13% red, 14 and 16. This is 15 years of data collection I've done with my 244 classes.
Wow.
If you've been to my office, when you walk into my office, off to the left, there's a picture of M&M's, one of my students took and dressed it up in Photoshop, very nice. 2 clipboards underneath. Left clipboard is the letter I send to them every 3 months with my new data. telling them that their percentages are wrong and they should think about changing them. And to the right is the clipboard with their rejection letters to me every 3 months saying, thanks for playing
Have
again.
percentages anyways. This seems ridiculous.
It gives the illusion of science.
Yeah, that's
But you're going to give me numbers, I'm going to test them. My point is this. Look at the numbers I get versus the numbers they say they should be. Now, granted, orange is spot on.
Yeah.
But look at blue. Look at
And the
green.
red.
Look at red.
Yellow's similar.
Yellow similar. Brown's within 5%. That might be a margin of error.
I'm glad green's higher.
But some... You're glad the green's higher? That's okay. That's fine. But the idea is that I'm seeing a discrepancy. So in other words, what they're telling me is different than what I'm seeing. I'm seeing outlier data. What's the next question I ask? Maybe who cares here, because you don't think about it. But I want to know why. Why am I getting different percentages? And I get the same stock response back every time. Well, our machines are calibrated. I'm like, no, they're not. If they were calibrated, I wouldn't be getting the data I'm getting.
Yeah.
But they never bother following up my follow-up letters. But, so I leave it at one letter for the most part with those guys, and I look at other things like this. And the idea of outliers is sometimes they actually show a meaningful, albeit unexpected occurrence. So, I read the book Outliers. Have anybody read that book? The book, it's called Outliers by Malcolm Gladwell. It's a fascinating read if you get a chance. And one of the things he mentioned was his wife and him were sitting at a hockey game, I think about 10 years ago. And his wife was going through the roster of the team they were going to watch. And she's like, well, that's interesting. And he goes, what's interesting? And he's like, most of these guys are born in January, February, and March. And he's like, really? And he looks at the book, and it's something like 90% of the team was born in the first 3 months of the year. And he started thinking about it. I said, why would that be? And his conclusion was interesting. Do you know what his conclusion was?
It's because they're older, so when they're younger, they're bigger, they're better, they're stronger, because they're older.
Caitlin nailed it. That was his theory too. You can't prove it, but it's pretty well supported by professional
like
sports.
the people born the same year but later in the
When they're
year.
4 and 5 years old. Think about Pee-wee hockey leagues, like Canadians, eh? Right? They start when they're tiny. They got them on skates when they're fetuses. They start skating 4 years old. They're in Pee-wee leagues. Who's bigger? A 4-year-old born in January or a 4-year-old born in December? The 4-year-old born in January, because he's got essentially 25% more life growing above the 4-year-old born 12 months later. Even though by year they're both 4 years old. It doesn't make any difference when we're our age, but it makes a huge difference when you're this big and the coaches are looking for those bigger, stronger kids. I'm going to take the word better out of that. Caitlin, it's okay, because they might not necessarily be better, but they are bigger and stronger, and the coaches grab them. And they make them better just by paying more attention to them. So I started looking. I said, does it apply to the Portland Timbers? Or does it apply to the men's national team? Men's national team just uses soccer. There's Americans in the audience, I apologize. So, men's national team, there's a big sporting event going to happen in about 3 months. It's called the World Cup. You might want to watch just a little bit. It's pretty fun. Does it appear to happen at the men's national team level? Well, here's, let's see, February, January, March, April, May, June, July. Not so much. This is November. Here's October, November. Where's December? December, March. That's December.
No, that can't be. That's
What's this? 1, 2, 3, 4. That's November, January, February, March. Maybe a hint of it. Maybe a hint of it. There's a large slice over here in September, but these 4 slices make up half of the circle, which means you've got half of the men's national team being born in the same 4 months, 3 of which are early in the year. That could be a hint. This is just the men's national team, the 20 plus. I'd say go look at more of the league and see if that holds. How about the Portland Timbers? Portland Timbers? I see less of an obvious kind of split in that one. So again, this is hardly a numerical calculation, is it? This is hardly, a lot of you look at that like, I'm not seeing what he's seeing. That's okay. In 244, we'll actually design a test that allows us to run this through a sausage grinder and pop out a measure of unlikeliness or likeliness. But that's the kind of stuff that outliers show you. Okay, there are too many born in the early part of the year. Why? Then you start thinking statistically, not statistically, but contextually. I'll leave you with one to think about. My little guy, Max, started riding a bike right before his 3rd birthday. Boggled my mind. Right before his 3rd birthday, on a bike, pedaling, keeping his balance, happy as a clam. I cried more that day than any other day, except the day he was born. And after I got done crying, the day was over, we were all exhausted, taking pictures, taking videos. It's ridiculous, completely ridiculous, Natasha, I agree. But after the day was over, I started thinking about it because I'm me. I was like, my God, he was 3, not even 3. I called my mom. Mom, when did I start riding a bike? She said, you were 6, 5 and a half, 6 years old. What the hell's wrong with you? So I couldn't leave it at that, of course. I said, all right, let's plot it. So here's the number line. 0, 3 years, 6 years. Max, when he started riding a bike? Me. I started riding a bike. Okay, it's hard to get anything from that. It's hard to get anything from that. So I started calling my friends that I grew up with back on the East Coast. Cook, when did you start riding a bike? He's like, why did you call me 11:30 at night to ask me this question? I said, dude, put the beer down. When did you start riding a bike? He's like, I don't know, dude, it was like kindergarten. I'm like, aha, I knew it, kindergarten. Call my buddy Chris, Joe. Who else did I call? Kelly, Nowazik. And essentially, I developed the idea that we all basically rode our bikes around the same time. And you know, you can cheat for a Velcro on them if you want, whatever. The idea was we had a cluster over there. So what does Max appear to be when compared to my East Coast friends?
Badass.
A badass. AKA an outlier, but I'll take badass. I think he's a pretty badass little dude. Yeah. But then what did I start doing? I started looking at his friends.
Oh, because West Coast.
Maybe there's a variable I'm not measuring for, right? So I asked Owen's parents, when did Owen start riding? Oh yeah, Owen started riding like 2 weeks before Max. Now Owen was actually older, so they essentially both started riding right around 3. And Lily and Jess, and I started getting the idea that that was Max's friends' curves. Caitlin.
Is it because there's a large gap of time between, like, different generations?
One argument, absolutely. Absolutely one argument. I love that argument, yes. East Coast versus West Coast, another argument. I love this. I came up with a different one, but you guys can't possibly know what it is yet. Keep coming. Why the differences? I got 2. East Coast, West Coast, generational gap. Richie?
The bicycles are better, and they're better set up with the training wheels.
He didn't use training wheels.
More
Wouldn't
people
let him use
have
it.
Well, the bicycles are better set up with the
Training wheels, FYI, worst thing you can do to a kid. But go ahead, keep going, Richie.
They fit on the bicycles better, I think.
They do, but none of his friends use them. Hint, hint, hint. None of his friends use training wheels. What did they use?
Their parents.
That's what they all used. Well, the parents is a good one that I can't measure, because none of my friends remember if their parents were like, okay, I ride a bike every day, like to a fault. So Max always, he sees me in a car once a month. He sees me on a bike once a day. So he's got this definition of normal, poor kid. Normal is daddy in a spandex getting on a bike. Like, that's like normal. Poor dude, I'm creating psychotherapy like on a bike, right? I know I'm kidding, Natasha. I think it's a wonderful thing to see, right? But the idea is, the big difference is every one of these kids grew up on a Strider bike. Balance bikes, as Sarah put. So what we did was we took an old Fisher-Price bike, chopped the pedals off, sanded down those cranks, and Max pushed himself around this thing from the age of 2 till the age of 3. So he's walking around with this bike, steering, in the house, out of the house, on the driveway, chasing the cats. And then as he got better at it, he would start lifting his feet up and coasting on the bike. So while he's getting the idea of sitting on a bike down, what else is he getting?
Balance.
Which is exactly what training wheels rob you of. Training wheels rob you of the balance. So then you put him on a bike at the age of 2.5, and I spent a lot of time holding that seat, running behind him. Don't get me wrong, it's a lot of work if you've done it. But then you let go at 2 years, 11 months, and he pedals away, and you're like, okay, and it's over. And that, I think, is the variable. I think. Might be an East Coast, West Coast thing. I never saw those things before. Maybe it was a generational gap because they didn't exist back in the day, because it was all about training wheels, as Richie said. And that's how I learned. But eventually, this idea of balance bike comes along, and that's my assignation to what the differences are. So that's why you care about outliers. They might even be giving you a clue. They might be showing you, oh, here's a different data set. Why is it different? Balance bike. Boom. Done. Maybe something else I'm not accounting for. I don't know. Make sense? I'll put an outlier quiz up for next week, maybe even 2 outlier quizzes. I like this idea. Just be practicing both ways, making sure you're familiar with both of them. Hello Kitty backpack. Absolutely. Outlier. Love it. Don't forget your project on Thursday, yeah? Email me if you get stuck. Don't wait till Wednesday night, midnight to start it. Please, that's hellish. It's a hellish idea. Be well. Stay, I was gonna say warm, stay dry. I think it is warm.